Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host as usual is Tobias Macy, and today I'm interviewing Matt Warren and Chris Kirkos about the ways that they are using Python at Wanderu. So Matt, could you start by introducing yourself?
Sure. I'm Matt Warren. I lead the tech ops team at Wanderu. Been there about 5 years.
And Chris, how about you?
Hey, yeah, I'm Chris. I am a computer scientist, and I've been at Wanderu for close to 5 years as well. And we've, both Matthew and myself, have seen Wanderu through most of its growth from small startup company into the scale that we are today, a profitable business.
And going back to you, Matt, do you remember how you first got introduced to Python?
Yeah, I do. My senior year at Northeastern University, I was taking it was like a data science-y kind of class maybe, but we were writing a sort of a web scrape algorithm thing. And I decided this seems like a really great task to do in Python. So I gave it a shot and it failed horribly. And I went to the TAs and they said, well, we all know Perl, so can you just rewrite it in Perl? I said, I mean, I guess. So that was my first experience. But then when I started at Wanderu, there was a bigger knowledge set to pull on there. So, Wanderu is really where my background in Python was solidified.
And Chris, do you remember how you first got introduced to Python?
Yeah, I was in an R&D setting, and one of the sub communities of Python before it was a really big language was the scientific community, and there were lots of tools that scientists were using that were all based on Python. So I got introduced to it through R&D. I was writing a lot of C++ at the time, and I was trying to be as productive as possible, but there were a few things that I couldn't do. There weren't libraries for things. I was doing a lot of things manually. So I stumbled on Python as having all of these modules that were supporting different things. So I can just import a module, and all of a sudden I got this whole world of functionality. Whereas before writing C++, I had to write all of that by hand, and it was just as good and just as fast. So I ended up using a lot of Python along with my C++ to speed things up. And one of the earliest applications that I wrote in my software engineering career was a C++ based application, but I embedded a Python interpreter into it. I took the Python DLL, loaded it into the program, and started using Python modules from C++. And I thought that was really, really cool. It allowed me to move a lot faster than it would if I had to build all this functionality out in C++ myself. So that was really neat.
That's funny. Most of the time you hear it going the other direction where somebody is using Python to call in C++ libraries, but you sort of flip that on its head to just call Python from your C++. It's not often that I've heard people do it that way.
Yeah, and I don't think it's done too much. What I ended up doing was I used it as a way to add scripting support into a library that I was already using. So if you needed to it was performing data transformations. And so if you wanted to write a data transformation, you can just write it in Python, and then we can build that into the application. All of a sudden we have a new data transformation available. And so we would load the modules that it found, and it could just call into those. And it was just a much easier workflow than it would be to have to write that module in C++ and recompile it all the time, and just allowed us to move faster. So
yeah, that's definitely very cool. And so now you're both at Wanderu, and I'm wondering if you can just start by describing a bit about what it is that Wanderu does and how the overall technical platform is architected.
So Wanderu is a meta search company for focusing on ground transportation. So think buses and trains. And ferries and other things too. We're incorporating flights and hotels as well, but it is mostly traditionally focused on ground transportation. So if you want to get from point A to point B, and then you go to Wanderu, you do a search for how do I get from point A to point B, and we show you your ground transportation options. Take a bus, take a train, put two things together, take a bus and then a train, and all using ground transportation. And we're slowly continuing to build out the platform to be a really reliable point-to-point search. And we've started in the United States, and we've grown to encompass most of the United States in terms of coverage. And now we're also expanding out into Europe, and where we've been building out a lot of our coverage in Europe as well. And then besides the meta search aspect, we also post current travel related content on our blog. And so we'll do data posts, and we'll do travel posts and things like that, and try to deliver some good travel content to our subscribers. The site itself, the platform is architected. It's a microservice architecture. We use Python, Node, and Golang, as well as a combination of databases, MongoDB, Postgres, Redis. We host the whole thing on AWS. And we started out as just a really small Django application as a startup. And slowly that grows. And the most interesting thing is essentially we're doing the same exact thing that we did when we were just a few months old. But now at scale, it changes the entire picture of the architecture. So how we're hosting on AWS in multiple regions, and what kind of message buses we're using to communicate between processes, and how we scale to hundreds of users, simultaneous users on the site, and all of that.
And so, given that you are now using more languages beyond just Python, now that you have split it out into these various services, I'm wondering, what are some of the broad categories where you are using Python, and the sort of litmus test of where it fits best and when it's best to use a different language?
Yeah, so broad categories for Python include DevOps for monitoring, provisioning, and deployment. Lots of command line tools and scripts, but we also use it for web services and middle tier microservices. So, like I mentioned before, we've had Django as a web tool, and then also Twisted. So we've used both as web frameworks. And the other way we use it is data warehousing and pipeline processing. So ETL kind of pipeline processing. So we use Python mostly for that as well. So it's all over the stack at Wanderu. It's the only places where we don't end up using Python are places where we've had to achieve a high level of concurrency, where we've decided to pull in Node, and places that we've had to be compute intensive, that we've decided to pull in options like Golang or a database or something to help us out with those situations.
And have you found that, particularly in the compute-intensive areas, that it was faster and easier for you to implement solutions using Go versus writing a C or C++ or Rust binary that you can then call into via Python for tying everything together?
Yeah, I've gone back and forth on this so many times with some of the performance aspects of our system. The timeline is really important when you're at a company. How fast you can deliver the thing that you need is very important, especially a small company, especially at a startup. And we tried building it out in Node, and that implementation failed us at scale because the memory requirements, and we couldn't really pin down how to optimize it properly. And we also did some testing in Python. We also used a graph database and other kinds of databases that were supposed to be good at those tasks. And ultimately, it came down to knowing that you could build a thing a certain way in a certain timeline, and that's why I chose Go for particularly to do some compute intensive processing in our stack, was basically because I knew that I could just build the thing we needed, and instead of going through more of the prototype R&D phase and potentially wasting time. So we chose it because we knew we could go for it, rely on it, the most reliable in the timeline.
And just briefly curious, which version or versions of Python you're relying on in your technical implementations?
We have to use anything older than Python 2.7.9 for talking with some of our partners, because that's the version that
because
introduced...
of the TLS issues?
Yeah, TLS 1.2. Got to have that in there.
Yep.
So that's sort of the minimum, but we have stuff. I think we just rolled something that uses Python 3.7, right?
Yeah, I think that was, what is it? One of the systems that's using, what is it doing? It's processing emails, right? We have an email processing system.
Right.
That's using async IO and Python 3.7, and it's also, I'm very jealous because I'm still working on a system that's using Python 2.7, and I'm itching to upgrade to Python 3.
Yeah.
And in those services where you do require that high concurrency and high throughput, were those implemented at a time where the async story for Python wasn't yet at the state where it is now? And if you were to start over again, do you think that you would change the decision of what the implementation strategy was for those?
Yeah, we chose Node as a technology for concurrency specifically for that scenario. I mean, it's really fast, and its concurrency model is excellent. It's evolved over time as well, and it was at a point in time when Python didn't have the same kind of concurrency that Node did. We didn't have async IO, but we had other tools that existed. We had Twisted, we had Gevent at the time, and those things were excellent. But I think the people who were deciding on the technology at that time were more influenced by the scalability of Node than by the scalability of Python. But I think one of the best things that has come out of Python 3, especially hitting Python 3.6, is async IO. I think that brought Python into the future. I would not start another project that relied on synchronous Python. I would only start a project that would rely on async IO from this point forward, because it is so highly performant. So bringing that into the core library and into the core of Python was one of the best moves. So if we had to redo it all over again, if we had to build something new, I would not hesitate at all to put Python right in the front, where we would normally put like a node process.
The Twisted stories, sort of like just a big accident for us. We started off, ingesting a bunch of data from various carrier websites, and there's a project out there called Scrapey that uses Twisted libraries under the hood. And when we needed to scale it out to be a more distributed system backed by some, persistent queue that we can do some inspection on, Chris sort of headed up this project. But I think that's where we really fell into Twisted as a bigger framework that we could build a whole system on top of. And the last few weeks I've been working to introduce new improvements to that system, and it is nice to have at least something that translates into a Python 3.6 async, style of writing functions and whatnot. It's a little bit easier than trying to do that full brain shift where you're writing, a project that's using Python 3.6 or 3.7, and you're doing all these async things, and then you go back to a, purely 2.7 code base, and you think, oh, wait, I can't do any of that stuff. Well, you can, syntax will be a little bit different, but your basic structure can be somewhat the same.
And Matt, as somebody who's responsible for the deployment and platform of the overall application architecture, what has your experience been in terms of being able to deploy and update and manage the Python components of your platform? And what other ways are you using Python in terms of being able to manage that overall platform?
Yeah, I mean, there are so many options when you're trying to deploy Python code. The first thing that came to mind is, you just have virtual environments. And before I was writing a lot of Python at Wanderu, I was sort of really getting into Ruby, but there was only very outside support of running different versions of Ruby and isolating libraries and things like that. So, being able to use virtual environments and isolate packages and things was really nice. In addition to that, the bit that really helps us deploy out any solution is just the ecosystem of Python. You have all of these outside packages that talk to anything in AWS. Like there's an officially supported package for AWS. We use MongoDB as our, backing data store for a lot of our data, and the PyMongo driver is wonderful. The other, big tool that we use is Ansible, and we've done some custom tooling inside of Ansible, and to be able to do that in all one programming language is just a nice thing to have.
Yeah, I use SaltStack for all of my infrastructure management, which is also implemented in Python. And all of the applications that we build are primarily Django. So, as you mentioned, being able to keep everything with one language and one syntax reduces a lot of the cognitive overhead of shifting between the application infrastructure and the technical infrastructure, and being able to just sort of keep that all in the same space and the same way of thinking is
Yeah,
helpful.
totally.
And so, Chris, you had mentioned that some of the limitations that you've come up with when trying to use Python for implementing the application logic is some things around high concurrency and computational throughput. So I'm curious, what are some of the other limitations or difficulties that you've encountered while working at Wanderu that are related to Python?
Yeah, we've had a great experience with Python thus far. I think some of our difficulties has been, the async support. We fortunately had, as Matt was saying, found Twisted and had it as part of our infrastructure, and we were able to go from an synchronous code base to an asynchronous code base because of it. And the path from Twisted to async IO looks very seamless as well. And so we're very fortunate in that respect. So definitely the Python 3 upgrade. It's hard to upgrade legacy systems. And we started on Python 2.7 a few years ago, and I am determined to get us on Python 3 as soon as we can. But we've got a lot of momentum, and that momentum it has to go along with the momentum of the company. So that's tough. The other things that have been kind of rough in terms of Python was packaging. Obviously, that's been a big deal for a long time. But we've tried so many different things. I tried using namespace packages at one point, but then pip was messed up with namespacing. So we would have a top level namespace of Wanderu, and we put all our packages in a sub namespace of that, Wanderu.data, Wanderu.core, stuff like that, so that we can segment our functionality into packages, and then just dealing with little hiccups that come along the way with trying to package and deploy our code. So that's been a little challenging, a little bit of a test. As Matt was saying, the SSL issues were definitely a fight. We had to do a lot of debugging and figure out what exactly it was doing, why it wasn't negotiating TLS 1.2 when that was necessary, and in different scenarios, and just getting development environments up and running, compiled against the right version of OpenSSL, and all of that. And those problems have seemed to go away over time, but we definitely bumped into them a bunch. I think the other things that have been important to us have been logging, and that we've spent a lot of time trying to get our logging into a place that is very useful for us, where we can put it into a database and dig into what's going on, have structured logs and things like that. And we've got it to a good place, but it's still not perfect. So I think we spend probably an inordinate amount of time on just trying to get logging right, and overall just tracing, debugging, things like that in our systems.
And Matt, have there been any other particular edge cases or difficulties that you've encountered in terms of your use of Python at Wanderu?
The one place where it really sticks out to me is funny because, we talked about the benefits of using Scrapey, and it helped us a lot when we were starting out. Unfortunately, we were using such a new version of it at the time that there were some breaking changes in the versions immediately after that. And we've had a heck of a time trying to upgrade that or isolate it or change it or what have you. And at one point there was an unrelated change in, oh gosh, was it Twisted or no, it was in cryptography, and the version of setup tools that cryptography needed bumped heads with this version of setup tools that Scrapey needed. And we just got into this weird place for a little while there, but it all sort of worked out. And actually, the community of people supporting those projects, we were able to open bugs and get some of those things resolved. So like at the end of the day, things have been pretty good, really.
And have there been any places that Python is used at Wanderu where you were surprised that was the choice, where you would have thought that some other either language or service or platform would have been implemented instead?
Yeah, I think we use Python. One of our largest code bases in the company is in Python, and it plays a very critical role to our entire stack. And for the number of lines of code and the complexity of the project, you would assume that something like Java was being used to power it, where there's a little more structure, a little more meat to the language that you're using. I think traditionally people consider Python good for either data science or for scripting or these other isolated smaller or web frameworks. But we have a pretty large system that is all built in Python. It's performing really well, and like I said, we've founded a lot of that on Twisted, and so it's very concurrent, serving out a lot of requests and playing a really big role in our entire stack. I think one of the projects that gave me hope that we could achieve that kind of scale with Python was OpenStack. Like I remember utilizing OpenStack for a while and just looking at the size of that code base and what they were accomplishing with the microservice architecture and all of how it was all working together. That was the first example where I saw a really big, cohesive code base, all built on Python, all working really well. And I think that example gave me some hope that we can actually take our scrappy startup code and turn it into a scalable system that's like critical to our business. So I think it surprised me in its ability to scale and accomplish what it's helped us accomplish.
So as you have scaled the company and the platforms that you need to be able to support the business, what are some of the areas that have been most stressed and have required the most amount of work to be able to scale them out?
Yeah, I think the compute intensive processes that we have, those have been the hardest. When, like you're saying, being able to find routes efficiently and things like that. It helps when you have a really fast, solid database and people who understand databases to offload a lot of that kind of processing. But sometimes you just need that speed and that parallelism. And in those scenarios, that's been the tough parts for us.
Yeah, to give you a specific example, and this wasn't necessarily Python's fault, but we were trying to iterate quickly over one particular Django application, and we had a bunch of data in MongoDB that this application was, querying through an API and then running a huge merge over multiple documents to then come up with the page to present to an incoming user. And it was one of those things where this Django application predated me and we just kept swapping out the data source, and it just got to a point where that was no longer going to be scalable, and we finally rewrote it in React and changed the underlying database and all those kinds of things. But there was so much stuff going on inside of that application. It was crazy.
And as you have been working at Wanderu and adding new features and building out the platform, what have you found to be some of the most useful libraries or language features that enable you to get your work done?
Yeah, I think Twisted has been pretty critical for us. I wish it was a little bit more supported nowadays. I think everyone's going with async.io and all of that, but that's been pretty critical for us. Requests has been a big deal as well. That's probably one of the most used libraries out there. And I think all the drivers, the database drivers, have been incredibly important. Just having really strong database drivers and support for that kind of stuff has been pretty critical for us.
And how about for you, Matt?
Yeah, I could name the big ones, Boto 3 and stuff like that. I think more recently I've been doing a lot with PyCountry. I'm migrating from sort of one data source to another, and PyCountry has provided a lot of glue where I can query information without trying to statically grab it myself. There's always just the one-off thing that will occasionally fill in a gap for you. And you're just like, oh, this is great. I'm so glad somebody wrote this.
And conversely, which libraries or language features have you found to be the most painful as you tried to get things done?
Yeah, we've bumped into a bunch of issues with XML and SOAP parsing and generation. And that's never that much fun. Generating valid XML documents, but they're not being accepted, and and things like that. That's been a bit of a headache. So we do a lot of XML templating with Jinja and all of that instead of using some XML sort libraries and all that. So OpenSSL, like Matt was saying, and Scrapey have both caused us a bit of pain with dependencies and upgrading and SSL things.
Matt, if you could share some of the pain points that you've experienced as well.
I think I'm with Chris on this one. I'm not sure. I don't think we've had too much that's been really catastrophic. If something doesn't work, there's probably another package that'll do it a different way. So apart from the things that are really integrated into what we do and how we do it, I can't think of much.
And in terms of your development processes for Python in particular, but also in any of your other code bases, what are some of the ways that you're using Python in terms of the tooling or unit tests or things like that?
We try to stick with the standard Python unit test frameworks and everything built into the language as much as we can. But we use PyTest, and we have code style standardization, and we do unit tests as much as we can. We have some integration tests, and we try to maintain a clean separation between what's a unit test and what's an integration test, and when we run a unit test versus an integration test. So the build system that Matt has put together, we utilize Jenkins and some other processes, but we set make sure our unit tests are run before any of our deployments are run. So our unit tests, if they fail, they block deployments in our automated infrastructure, and that we rely on that kind of stuff all the time. And really, beyond that, for us, it's mostly about setting some standards and making sure that everybody understands them and follows along with them in terms of how they do unit testing, how they do mocking, and how they do integration testing, and what the differences between those are, and just setting standards for that kind of stuff. That's the most important thing. But we've had great experience so far with just unit tests and mocks, and they've done a lot for us.
Yeah, PyTest is pretty awesome. I'll also say something I recently found and we need to, or I'd like to see us do a little bit more with is a thing or a library called Bandit, which is a security vulnerability sort of scanning tool. We don't have a lot of external facing Python code. A lot of our code makes calls to other things, but nothing or not a lot calls into it. Bandit does a good job of, scanning for known Python things to avoid and any published vulnerabilities in the libraries that you're using as well. They can look some of that stuff up.
And are there any other aspects of the work that you're doing at Wanderu or the platform that you're building or some of the business challenges that you're facing or ways that you're using Python to achieve any of those things that you think we should cover in greater depth before we close out the show?
Sure, yeah, I can just say a few other things about our technology choices and why we choose Python. I think the most important thing for us has been our ability to work with each other in the company, and that seems a lot on all of our knowledge of Python. Everyone in the company has an understanding of Python, and or on the tech side, that is. And it's really good to be able to, as a small group, cross teams and work with each other technically. And so having a language that's both amenable to beginners and experts alike is really important for us. So beginners can jump in and use Python, and it's also good for experts who really know what they're doing. If they want to write a C extension or a Rust extension, or they want to optimize it in a certain way, you can do that with Python. So it's really very flexible in that respect. And so that's been probably one of the most important things for us, as well as a rapid prototyping. It's easy for us to rapidly prototype a tool in a week or a feature, and then take it to production after that. We use a lot of the code that we built in a prototype and flush it out, make it production ready. So having the ability to go to the rapidly prototype and build it out into a production system is really important for us as well. So as a small company, speed and flexibility is really important. I think one of the challenges, though, as you scale with Python, ends up being this. This is probably true for most dynamic languages. They don't impose too much structure on you. They assume that you know what you're doing and you know where to impose your own structure. That's a part of it, of using a dynamic language. And so knowing where you should create structure is important. Where a piece of code is going to be repeated multiple times. You're going to create a pattern. You're going to create a set of models or a set of controllers or a set of classes, and you're going to establish a pattern, and then know that pattern is going to be communicated and copied over and over again, repeated in order to achieve scale in that part of the system. But you have to put that structure in place with a language like Python. You don't necessarily get a lot of the standard tools that you get with Java, where you're gonna use the language, you're gonna use the design patterns from the Django book, you're gonna use the debugging support and Eclipse and all of these tools. You've got this set ecosystem that you set up for yourself, and you build it. You don't really do that with Python. You have to build your structure as you go. So it's important to be cognizant of that as you scale.
The point about having people across the tech group all know Python is kind of cool, because it's not like we've gone and hired people who had a very strict Python background. We've had a number of people who came in not knowing any Python, and they've been able to pick it up and learn very quickly and come up to speed with what we're doing with Python. The structure, helps with that as well. It's just, you can sort of repeat something, and once you understand it, you can extend it and all those kinds of things. So Python's been paying off in really nice ways there as well.
Well, for anybody who wants to get in touch with either of you or follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose the Data Grip tool from JetBrains, which is their general purpose database client, which has support for a large number of drivers and database platforms. And I've found it to be quite useful for my day-to-day work. So I've gone through a number of different database clients over the years, and DataGrip has been one that's had a pretty good amount of sticking power. So it's definitely worth checking out if that's something you're in the market for. And so with that, I'll pass it to you, Matt. Do you have any picks this week?
Yeah, you know what? We moved offices recently, and I will say being very close to Chacarero is super nice. So I'll pick that. If you've ever been over to Chacarero, it's meat, beans, and tomatoes, I think.
And Chris, do you have any picks this week?
I've been on a debugging kick lately, so I'm going to give some props to PDB, IPDB, PUDB, and the one that ships with VS Code. What is it? I forget the one that ships with VS Code, but I've been using VS Code lately, and having that with an integrated debugger and being able to attach either to a remote process or to my locally running program and figure things out has been incredible. I cringe at the use of print statements, so most of my guys here would definitely tell you that I get pretty upset about print statements. But I love the debuggers and the debugging support, and I just hope that Python keeps progressing in that front with tracing and all those kind of tools. So mad props to IPDB, PUDB, and the one that ships with VS Code as well.
All right. Well, thank you both very much for taking the time out of your day to talk about the work that you've been doing and the ways that you're using Python to do it. I hope you enjoy the rest of your day, and thank you again.
Thank you. Yeah, you too.
Thanks, Tobias.